at the beginning of last year, I had a look around. So what's next? What is the next level of electronics manufacturing? What will be the next generation? And then I looked around, and then I found this.
Hello, everyone, and welcome to the Altium OnTrack podcast. I am your host, Zach Peterson, and today we will be talking with Alexandre Schafer, Business Development Manager of J.A.M.E.S. For those of you who are in the electronic space, you may not know about J.A.M.E.S, but they do operate in the area of additive manufacturing of electronics. So I think this is going to be a very interesting discussion relating to a upcoming and very important technology for producing PCBs. Alexandre, thank you so much for joining us today.
Thank you for the invitation. I'm happy to be here.
Absolutely. So I've been seeing you on LinkedIn quite a bit. I try to follow the developments in additive. Sometimes it is quite difficult to keep up, but thank you so much for being here. And I think one of the things that I was wondering about, and maybe you can just tell the audience first of all, is what is J.A.M.E.S? What does the company do? How did you get involved?
J.A.M.E.S is a joint venture of Standardization and company Hensoldt, and our vision is that we want to push the AME technology itself. So as you know from different technology forecasts and market researchers, they say the AME technology will be more or less available in 2025, 26, so around that. And the question is, why does it took so long? Because we are on a very good way. And the answer from our point of view is there's less exchange between the stakeholders, and there's no community and no synergies between the different stakeholders in this case. So when we say on a technical readiness level between 1 and 9, we are between 4 and 5. That means we are between experimental and demonstration pilot currently. And we want to accelerate that as fast as we can. And we want to do this with crowd development in combination with our own research. So, and J.A.M.E.S created the first online platform where we have a lot of people together from different areas, from different stakeholders, printer manufacturer, AME experts, user, also industrial partners with applications and so on. And we want to bring them all together to push this technology itself and to make it more accessible for the whole industry. That's our vision and our chance to push this. Yes.
So in terms of your background, how did you get involved into the additive manufacturing side? Because I'm always interested to hear people's stories, how they got into their particular niche in the electronics industry.
Yeah, sure. So in the past, I worked for companies who were active in semiconductors and also in the traditional PCB manufacturing. And during the years, I learned a lot about the processes and how the development works of different systems and so on. And at the beginning of last year, I had a look around. So what's next? What is the next level of electronics manufacturing? What will be the next generation? And then I looked around, and then I found this. I hope you can see it. And this is a drone frame. And this is printed with AME. This is a very, very cool project from a colleague of mine. And I said, okay, this is very interesting. I want to know more about that. And that was the reason why I started researching about this new technology and all the possibilities of that. And I'm totally convinced of this AME technology, and also I'm convinced of the idea behind J.A.M.E.S. So I like the vision and the idea to develop this all together. I think this is a really good thing. And so I joined J.A.M.E.S in April this year, and now I'm responsible for the business development. That means I'm in charge for new users, for our partnerships we have, and to increase the awareness of AME technology itself, and also for J.A.M.E.S. So the face of J.A.M.E.S, let me say so.
So you brought up an important point here about the status of this
Yes.
technology. And you said between technology readiness level 4 and 5, and I don't have all of those memorized, but it sounds more like low volume or even just prototyping is really where the industry is at. Would you say that's a fair statement, or would you say that it's starting to get beyond just being something for prototyping and demonstrations or research and getting closer to maybe low volume, high mix?
Currently, we are on the stage of prototyping. We are trying to get to the next level, but currently we are facing a lot of challenges in the technology and in the process itself, and also in the mindset of the people. So one important fact of that is to change the mindset of the people, of the engineers, and yeah. So let's say this is the most important fact currently. So to think out of the box. Some days ago, I had a really interesting chat with a guy from the FED. This is, let me say, the German PCB community or something like that. And they are well organized there, and they are working on a lot of standards and all the things that around PCB manufacturing and PCB design. And he told me the same, because he's also convinced of this next step of this 3D technology, the fully 3D, not print PCB in AME, but we are talking about real 3D structures. That means 3D wiring, free wiring, imprint, chipsets with micro dispensing or something like that. That is what we're talking about. And he also told me it's very, very hard to convince the people from this 3D idea. And they are thinking in their PCB structures. And yeah, it's not easy to show them what are the possibilities and why they should change from 3D into 3D design. And the next challenge is if you convince somebody to make something in a fully 3D way, the next question is, which tool can I use to make this? And currently there is no tool available. So at the moment we have to use an ECAD tool for the electrical design and an MCAD tool for the mechanical design, and then we have to merge it manually. And that means this process is very error prone currently. You need to concentrate on it, and then to define, to bring this ECAD and MCAD together. So we need a merge of this in the future. So we need a tool that makes it possible to design electrical, to make electrical design and mechanical design both together. I asked my engineering department, as I told them that we are talking about together with Altium and so on, and I asked them, okay, what is your wish? What you want to have? And they told me we need a fully working 3D auto router. That would be very good to make such designs. And yeah, we are also in touch with some guys from Altium. And yeah, so maybe Altium can make this dream come true one day. Yeah, but let me say so, Altium is on a good way, because they are doing the first steps in this direction. I have seen it on LinkedIn. There is a possibility to make free wiring on MID structures, yeah, some to print some wiring on existing surface. This is really good step, and yeah, we're staying in touch with some colleagues from Altium, and we are showing them that there's more to do, and this is also what we are doing with our collaboration platform, with our idea with J.A.M.E.S. We want to show, okay, there is a need, there's a big crowd, and they want to develop such things. Currently they can't that easy as it could be. And we want to show also to the software development companies to say, okay, hey, there's a big crowd, please do something in this case, and there's a critical mass for you to develop something. So that is also an important thing that we are doing currently. So yeah, this would be great to have in the future to convince more people to do it in fully 3D structures.
The question I guess I have is about, this kind of standardization between maybe ECAD and MCAD, because it sounds like, from what you're saying, there are probably some structures in an additively manufactured PCB that look very similar to what you would see in a traditional PCB, like horizontal traces and maybe polygons and things like this. So those are easy to define in like an ECAD program. But eventually there's some structure that you might like to place. Maybe it's like a coaxial type of interconnect, because I've seen that from some of Nano Dimension's designs. At some point you have to then have a tool that allows you to create those kind of 3D structures. But it sounds like there's a real challenge with standardizing what those 3D structures even are, right? Because in a traditional PCB, right, it's a via. We all know what vias are. But what are all those structures in an additively manufactured design? They could be anything, it sounds like.
Yeah, sure. You're totally right. So then currently we don't have any standards for that at the moment. This is also another challenge to work on this. I'm totally agree with you. Because with the 3D wiring we can the 3D wiring is a, let me say so, a very excellent benefit of this design of this 3D structures. So then you can get rid of the vias. But I totally agree. There's no standardization, no definition about how it works, and this is also a challenge that we have to face and to define something there. Yeah, that's totally true. Sure.
It's almost like the ECAD software has to be able to support placing a structure that you have designed in another tool, maybe like as a step model, let's say. And so you design this interconnect structure, you bring it into the board, you place it somewhere, you have a setting that you turn on that says, I'm doing an AME board, and then you can kind of place whatever you want as long as you have a 3D model available for it.
Yeah, yes, that will be a good thing to have, so that you can add everything you want, you can create such compact designs, and then you have short wiring, because the free wiring, you have short connections. That means you have a higher signal integrity, we have lower latency, and so on, and all the things. And and you can create very, very complex systems into very compact sizes. So, for example, when I can show you something, this is also a prototype, but this shows what I mean. This is the PCB project, and this is the same application. You can see, it's prototyping currently, but this is the same application, but in a fully 3D design. Let me say so. It's currently sliced because we are trying to realize this, but this is what we want to achieve. This is our goal, to come from the PCB design to this fully 3D wiring and so on. Yeah, and all the components should be integrated in this thing.
When you say integrated, do you mean embedded? Do you mean placed during the printing process? All of the above?
Yes, this is also another challenge, to merge technologies. So we don't need to merge the software things, we also need to merge technologies. So this means there are different processes available. So this is really good. We have inkjet, we have piezo, we have aerosol, something like that. We have micro dispensing and so on. So different technologies. And in the future, from my point of view, we need to merge these things. So that makes it available that we can use also to add the components, let me say, unhoused. You know what I mean? So that we can add. So we print something, then in this layer we add the component, micro dispense it with the micro dispensing process, and then we're using the inkjet to imprint it. So that's a possibility to do, but we need to merge this technology. Currently we have the micro dispensing, we have the inkjet, we have this, but in the future to make it more or to come to this fully 3D applications and real printing things, we need to merge this.
So what you're describing is I hear a lot of different processes going on at once that would really be needing to come together in some sort of standardized process. I'm almost thinking like an assembly line, but with 3D printing, right? Where essentially it goes from one portion of the process where you're printing maybe the base, and then you go into a micro dispensing, and then you inkjet the next layer. But during this, you also have to have the capability to maybe do some sort of unique structure that, curves along the interior of the board. So, I mean, it sounds like standardization is almost the enemy of freedom, because the second you start to standardize this, how can you guarantee that you can actually have the freedom that you want? And so I've thought about this a lot, and I feel like the more you try and standardize this and bring this into a high volume manufacturing type of technology, the more difficult it is going to be for somebody to really innovate. Would you agree with that statement, or is
Yes, yeah, sure.
Okay.
This is yes, that is the point. Yeah.
So what can some of the printer manufacturers actually do to try and support each other without really stifling the end user? Because I get that if you have this interoperability, it makes it easier to maybe scale up, which is certainly, what the AME part of, additive manufacturing, the M in there, manufacturing, implies you should be doing, which is scaling. What can the printer manufacturers do? How should they work together? And what's kind of the vision?
Yeah, so our vision is that they are all talking together, all the stakeholders of the different processes, and to share their knowledge. This would be very good. We are trying to do this on our platform, on our framework, because we're bringing all the printer manufacturers also together. In the future will be more and more, and we share things like, what do you have to adjust on this printer? What is an advantage? What you have to use for this? What design rules you have to mention for this printing process, and what's for that? So currently we have different design rules for different processes. That's currently the status, but that is I thought what you mentioned, that will have in the future an interaction between the companies, between the printer manufacturers, and they share their knowledge, and then they sit together and say, so our vision is, okay, to be honest, if all the CEOs of all the stakeholders sitting on a J.A.M.E.S desk together and talking together about AME and their processes, that's our vision.
I almost envision something kind of like what we do in the traditional PCB world, which is where you kind of have three classes of processes that are relatively standardized, right? There's the traditional process, which is not super high density. Then you get into HDI, which is its own set of processes. And then you have rigid and rigid flex. Or flex and rigid flex, I should say. Misspoke there. But you kind of see where I'm going with this, where they're all within the realm of PCB, and by standardizing some of those design aspects within each area, now the ECAD vendors can come in and say, we can develop a tool that accommodates all of this. Would you say it might be appropriate for all of the CEOs to come together and say, okay, we get that we don't want to stifle innovation, so we're going to come up with these maybe like 4 or 5 different like classes, let's say, of additively manufactured PCBs. So you have, let's say traditional multi-layer. That's simple. Traditional multi-layer with free running interconnects. That's another type of, maybe that's another type. So I'm just kind of, thinking out loud here and trying to draw that parallel between the traditional processes and then what you could do with additive.
Yes. Yeah, I think this will be, this These are, let me say, some steps from the traditional PCB, stepping step by step into a fully 3D design. So how
I think
can
doing that would also make it easier for new printer manufacturers or equipment manufacturers to get into the game too, because now they know
yeah,
what they have to
sure,
target.
sure. This might be opportunity that we can bring other manufacturers into this AME ecosystem. I fully agree with you. If you have a manufacturer that is his business is traditional PCB, and it's a long way from the traditional production, first to change the mindset and think out of the box and go completely into the 3D design. That's I fully agree with that. So maybe it could be a good idea to show them, okay, let's step from the traditional PCB into, and let's integrate some free wiring or something like that. Get off the RIAs. So that's the first step maybe. Then in the next step, we can see, okay, go away from FR4 material. We can use other materials because the AM ecosystem is very well developed and we have a lot of materials there available. And with this material, there's a lot of possibility to fulfill some requirements. And we're talking about thermal things and or whatever. This range of materials is really, really good. And yeah, this could be that we, when we're discussing in this direction also, then maybe we can bring more manufacturers into the game. Yeah. This,
Okay.
I think this could work.
I would hope so, because you've mentioned, changing the mindset, and a lot of the design mindset, I feel like it is often dominated by design rules. I need to know what the
Hmm.
constraints are so I can work within that and engineer within that. And when you
Yes.
start to say additive has no rules, it's like, well, now what do I do?
Okay.
Where do I start?
Yeah. Wow. What? No rules? What should I do?
Yeah.
Yes. Yeah. Sure. I know what you mean. Um, yeah, we are trying to develop some rules. Currently, we are trying to show the benefits. This is our most important thing currently, to make the people more interested in this. So we are showing some cool things like this or the drone or something, and to get the to get more visibility and more that the people are interested in. And then yes, to show that maybe, yeah, this is a quite good point, because there are no rules currently, and the creativity is really, really big. You can create systems what you want. You can create curves, you can create triangles or whatever. You can print everything. You can put in the components inside wherever you want. You can connect it. You save space and so on. Yes, maybe we need to create some rules to make it easier for the engineers to come from the PCB rules from their world into our world. It's a good idea. Let me think about it.
Okay. Well, if you ever have that roundtable meeting with CEOs, you should probably have a few rules ready to go.
uh, maybe.
So in terms of what the software could look like, um, do you think having kind of a rules-based system is going to be helpful for the software companies to develop a solution that then makes it easier to design these types of systems? Or is this really going to end up being a case where the printer manufacturers are going to have to build their own design tools? I mean, I think a smart way to go would be to build something that integrates into an existing
Yes,
tool. Altium does
yes.
that really well because it's got all the extensions and stuff. But I don't know what that would look like if all of the, let's say all of the manufacturers are going to start building their own design tools. Because if they can't agree on standardized constructions, let's say, for boards, how are we going to get them to agree on a system to actually design these things?
Yeah. I think currently it is so that every printer manufacturer do his own thing, also on the software side. And maybe it will be a good way when you found, and I think Altium, for example, is also a really great partner for that, because Altium has a really big market. So a lot of people are using this great software. And maybe we can do it like that we say, okay, maybe we can integrate this in a established software package or established software like Altium, and we can bring in the things from this process, from this printer manufacturer, so, and to bring them together to get in touch to talk about. And then Altium, for example, can take the needs or the rules from the printer manufacturer and integrate it into into the software. So step by step for every printer manufacturer, to avoid a lot of different softwares. So I think this will be not the best decision, that everybody will do his own software, because when I think I'm an engineer and I want to do something, and currently the processes are not merged right now, and I want to use an inkjet process also then a micro dispensing, then I have to use two software tools and so on and so on. And this, from my point of view, it would be better to integrate it in one software and one package.
Well, and I see some divergence also in terms of what the software looks like being challenging, because as you said earlier, this is still in an innovation stage. This is still
Yes.
getting out of demo and into commercialization.
Yes.
And
Yeah.
I think as soon as printer companies start developing their own design software, you would essentially have them at the same place. And so you'll have these competing processes within the software, and it's going to still remain to be seen which type of software or which development process within the software is going to win the day. I mean, it's almost like we're in the early days of the internet for AME, because we don't even know what it's going to look like in 2, 3, 5, 10 years.
Yes.
And
Yeah.
so you
Sure.
almost have to let the companies fight it out. Would you
Yeah.
agree with that?
Yes, I think so. And then this is also the reason why we have, or why we are trying to bring these people as early as together as early as possible. So to avoid that one company is doing a lot of software development, and then it will be much more difficult to bring this into, let me say, an Altium tool or something, because they developed a lot. They had a lot of effort, and then they say, okay, why should I do this? I developed my software, use my tool. So that's the reason why we're trying to bring these people together as early in this early stage, that we make it as easy as possible for the users, for the designers, for the people who have ideas for applications, to use these tools and to get more ideas, to create more ideas, more applications in this 3D design.
Yeah, that makes a lot of sense. So I'd like to maybe shift gears just a little bit, and wonder what types of initiatives is J.A.M.E.S involved in, or maybe is the AME industry involved in order to educate designers on what is possible and how to even think about how to design additively manufactured PCBs.
Yes, this is a real good question, because this is one of our most important thing currently. What we are doing is to educate the people and to share all our knowledge, because we are doing a lot of research by our own. We have our own lab where we have 2 printers inside, and my colleagues are doing every day printing something, trying new applications, changing some settings, and want to see what happened and so on. And we share this knowledge, and we want to educate the people. And we are using 2 ways to do this. The first thing is that we have on our framework a lot of designs and a lot of tutorials. We spend a lot of time to record step by step what you have to do to create such designs with this tool, and what you have to do to make it easier to get access to this and to get in touch with this technology and how it works. And another way is our AME Academy. The name say what you get there, because this is a channel to educate the people also in AME itself. So we are bringing some companies together that are work in this field, and we want to make it easy to get access to this AME technology. We have different different speakers, some workshops about different technologies, and we give the different printer manufacturer, for example, the possibility to present their technology, because for us it's very, very important to be neutral, because we are interested in to push this technology itself, not the inkjet technology and not the micro dispensing or whatever. We want to push AME. So it's absolutely absolutely needed that we are neutral and present give every printer manufacturer the chance to show what he's doing, how his process works, and to get the people a deeper view on all the technical things. So we are showing different processes, and this process owners can show their technology. So yeah, these are two ways we are using to share the knowledge, to educate the people.
So in terms of the knowledge being shared, right,
Yes.
I'm hearing a little bit with design ideas.
Yes.
I'm hearing a little bit with how the process works or how the manufacturing process works. What else is there? Is there maybe resources available for how to build these designs?
Yes.
Is there information on like materials, some
Yes.
of the more granular details like this?
Yes, definitely. On our platform, we share also some things to download. So also you can download the designs. For example, a very easy example is our J.A.M.E.S coin. This is a very easy example to get in touch with this technology, and we provide the tutorial step by step. We also provide the data the design data, the rules you have, and also the things you need to prepare to print it. In this case, it's inkjet process because we have nano dimension machines in our lab. But yeah, it's possible to download things. We share also the bill of materials, for example, and also tutorials how you can create some antenna design, some capacitors or something like that. Because this is also possible. We can replace some components from the shelf also. And there are a lot of information there how you can do this.
So is this an ongoing resource, or are there live events? How do people get involved in this type of thing? Because I think we'd like to direct some folks over to AME Academy so that they can get involved if they're interested.
Yes, the AME Academy is one thing, and really good idea is to signing in our platform and to have a look on it, because then you can see what we are presenting, we are sharing these designs and so on. So in the future, as the community is growing, we are working every day on new content, new applications, new designs, new things to download, new tutorials. And so the content is also growing because we are started our platform on the 1st of July. So we are online since around about 1 month, 4 weeks. And there are a lot of activities currently, and this will be more and more, because if we have more people, they are talking about, we have more synergies to use. And also the AME Academy is for free. You can join in this different things. And we also plan, not for this year, because it's not possible for this year, but for the next year, we plan our own let me say live event here in Munich with J.A.M.E.S, so that we will have our AME community here that we can talk face to face, hopefully. And we want to invite the people to get in touch together to discuss applications and so on. So there are some possibilities to get involved there. So, and you can contact us directly. So a colleague of mine are very, very well educated in AME, and they can answer some questions if we have problems with the printing process or whatever. We are able to help.
Well, what we'll do is we'll include some links in the show notes. So anyone that is listening and interested in learning more about J.A.M.E.S and about AME Academy and possibly getting involved, please check out the links in the show notes, and maybe even get a hold of you on LinkedIn if they want to know more. Are you okay with that?
Yes, sure. We can do that. You're invited to get in touch with me also. Sure.
That sounds great. That sounds great. Well, this has been very interesting, and I think it's important to get this perspective from someone who's maybe in your position as kind of the middleman between all of the players here, because at some point it seems like it's really your job to be the information aggregator in chief, if you will, to try and present all these resources to people who are interested in it. Because I know that sometimes I feel like with these new technologies, it is difficult to start pursuing it because there's so much going on, and there is a lack of, I guess you could say, standardization. And it almost seems like the designer is, a little divorced from it. So it's great to see that there's an organization like this that can try and provide these resources for designers. So I say to you, keep it up.
Thank you very much. We are happy that you see this so, and we heard it often that the people say, okay, this is a great idea to bring all the people together, and hopefully, it will work in the future. So, yes, we hope that we can push
great.
the technology. Sure.
Absolutely. Absolutely. I totally agree with you. Alexandre, thank you so much again for joining us. I think we'll wrap it up here. To everybody that's listening, please check out the links in the show notes and go get involved. This is an important area of technology. I've been a firm believer that this is going to be, at some point, the dominant way to produce PCBs, not just at technology readiness level 4 where we're currently at. So I truly do believe in it. And to anyone that is listening, you can check out those links in the show notes. Go check out or connect with Alexandre on LinkedIn. And of course, make sure that you subscribe to us on YouTube to keep up with all of the upcoming new episodes. And last but not least, don't stop learning, stay on track, and we will see you all next time.